Advantages of binary search tree. First one is efficient searching. Binary search tree allows for efficient search operation with time complexity of big O of log n in balanced tree. It eliminates half of the search space at each step. The next advantage is efficient insertion and deletion. In a balanced binary search tree, inserting or deleting a node can also be done in big O of log n time, which is much faster than operations in unsorted lists. The next one is dynamic structure. Unlike arrays, a binary search tree doesn't require resizing as it can dynamically grow or shrink with insertion and deletions. Next advantage is sorted order traversal. In a in-order traversal of binary search tree produces elements in sorted order, making it useful for applications that require data to be accessed in a sorted sequence. Next one is space efficiency. A binary search tree requires minimal space beyond the storage of its nodes, with no need of extra storage like hash tables for hash functions or linked lists. Next advantage is easy data retrieval. Binary search trees are useful when you need quick access to both minimum and maximum values, as these can be found at leftmost and rightmost nodes respectively. The next one is to support range queries. Binary search trees allow for efficient querying of range values between a given lower and upper bound, which is not feasible in unsorted data structures. The next advantage is flexible structure. Variants of binary search trees like AVL trees, red black trees maintain balance, ensuring efficient performance even when data is added in a way that could otherwise make the tree unbalanced. Binary search trees combine the benefits of both dynamic and ordered data structures, making them ideal for many applications involving search, insertion, and sorted data retrieval.